Dear students, welcome to our science episodes. Today we are going to continue discussing reflection and refraction of light. What do you know about absolute refractive index? The absolute refractive index is the ratio between the speed of light in air to that in another transparent medium. So this is the equation. Absolute refractive index equal to the speed of light in air divided by the speed of light in medium. The speed of light in air is always greater than that in any other transparent medium. So what is meant by the absolute refractive index of water is 1.33. This means that the ratio between the speed of light in air and in water is 1.33. What is meant by the absolute refractive index of a transparent medium is always greater than 1. And this is because the speed of light in air is greater than its speed in any other transparent medium. Can you calculate the absolute refractive index of ethyl alcohol, knowing that the speed of light in ethyl alcohol is 2.2 times 10 to the power 8 meter per second? So let's apply the equation. Absolute refractive index of ethyl alcohol equal to the speed of light in air divided by the speed of light in ethyl alcohol. So it's equal to 3 times 10 to the power 8, this is the speed of light in air. And 2.2 times 10 to the power 8, this is the speed of light in ethyl alcohol. This will give us 1.5 as absolute refractive index. Note that when the absolute refractive index of a medium increases, then its optical density will increase too, and accordingly, the speed of the light will decrease. Can you give reason why diamonds can refract light more than ordinary glass? This is because the absolute refractive index of diamonds is more than that of ordinary glass. Laws of light refraction. It states that when a light ray travels from a less optically dense medium as air to a more optically dense medium as glass, it refracts toward the normal at the point of incidence on the separating surface between the two media. The refracted light ray will be close to the normal, while when the light ray travels from a more optically dense medium, such as glass, to a less optically dense medium, such as air, it will refract away from the normal, at the point of incidence on the separating surface between two media. So here the refracted light is far from the normal. Can you guess what will happen when a light ray is incident perpendicular to the separating surface between two transparent media of different optical densities? What will happen if the light ray, the incident light ray, will strike the surface between air and glass perpendicular to the surface? It will pass without refraction, and the angle of incidence is equal to 0. How can we identify the real position of an object that is immersed in water? By looking perpendicularly to the surface of water, so no refraction happens. As a conclusion, for light to be refracted, it has to be inclined as it strikes the boundary surface between two transparent objects. The angle of incidence should not be 0. The incident ray should strike the surface inclined. If a light ray travels from medium A to medium B with an angle of incidence 50 degrees and an angle of refraction 40 degrees, which medium has greater absolute refractive index? Look at this figure. This is the angle of incidence, 50 degrees, and this is the angle of refraction. And we know that when the refracted light is closer to the normal, this means that we are going from a less optical dense media. This means that light travels from a less optical dense medium to a greater dense medium, and accordingly less absolute refractive index to more absolute refractive index. This means that medium B has greater optical density and greater absolute refractive index too. Natural phenomena related to light reflection and refraction. Number one, apparent shape of objects. Look at this pencil. It is partially immersed in water. Half of it is in the water and half of it is outside the water. And in the water, it appears as if it is broken due to refraction of light rays coming from the immersed part in water. So this is the actual position and this is the apparent position. Apparent position of objects. If we have an completely immersed objects in water, like for example fish, they are seen for fishes in an apparent position slightly above its real position. So this is the real position and it appears to this man as if it is here due to refraction of light rays coming from the object. Mirage is a natural phenomenon that takes place in the desert roads at noon, especially at summer. Objects on the road side seems as they have inverted images on a wet area due to reflection and refraction of light. Now it's time for questions. Write the scientific term. The ratio between the speed of light in air to that in another transparent medium. This is absolute refractive index. In deserts, objects are seen as inverted images on a wet area. This is called mirage. Give reason for the mirage phenomenon in deserts. This is due to refraction and reflection of light rays at layers of air with different temperatures, different optical densities. Fish are seen in an apparent position slightly above its real position. This is due to refraction of light rays coming from the object away from their normal position. Now calculate the speed of light in glass. If the light speed in air is 3 times 10 to the power 8 meter per second and the absolute refractive index of glass is 1.5. This is the equation. Speed of light in glass equals speed of light in air divided by absolute refractive index of glass. So the speed of light in glass equal to the speed of light in air, 3 times 10 to the power 8, divided by 1.5, which is the absolute refractive index of glass. It will give us 2 times 10 to the power 8 meter per second. Thank you. Dear students, thank you for watching and see you later in other science episodes.